In this video, we're going to be using DESMOS to calculate the correlation coefficient for data represented in a table. Once we have that answer, we're going to then use it to determine what type of linear association exists between the two variables. A counselor asked college students who had jobs how many hours they worked each week. The counselor then compared the number of hours each student worked and the student's overall grade average. The table shows the data. Based on the correlation coefficient for the data, what type of linear association exists between hours worked and overall grade average? So we're comparing two data values here. We're comparing the hours worked by the student and their overall grade average. We want to know, is the relationship strong or weak, and is it positive or negative? So in other words, the more a student works, should we predict that their grades go up, or are we predicting that their grades go down? And is the association close? Is it very closely related, or is it loosely related? So we're going to use DESMOS to calculate the correlation coefficient, the R value. But before we even do that, let's make sure we understand what correlation coefficient even is. A correlation coefficient is a number that goes from +1 to -1. In the middle is 0. 0 means that there is no relationship between the two variables, meaning that there's no correlation. If the correlation coefficient is exactly 1 or exactly -1, that means the relationship is perfect and it's going to form a straight line, as you can see here. +1, straight line going up, -1, negative line going down. Now, in the middle is where there's a little bit of ambiguity. Essentially, the closer a number is to 0, the weaker the correlation is. It's either a weak positive correlation or a weak negative correlation, depending on the sign of the R value. The closer the number is to either 1 or -1, the stronger the correlation coefficient is. Again, it's either a strong positive if the number is positive, or a strong negative if the number is negative. Now in the problem that we're given, we just have a table of values. The table isn't plotted, so we can't see the relationship. So essentially the R value tells you what kind of relationship you would have. If the R value is positive, the trend is moving upward. We just need to figure out the strength. Is it perfect? Is it strong? Or is it a little bit weaker? If it's a negative R value, the data trends down like you see here, and then the size of the number tells you if it's perfect, if it's strong, or if it's just a little bit weaker. Now let's go to DESMOS and enter in the data from that table and see what kind of correlation coefficient we get. Once you get into DESMOS, you're going to press the plus sign and make a table. The X value is going to be hours worked. That's your independent variable. And you do have to put in everything. If you miss any of the values in the table, the R value is going to be off ever so slightly, maybe even a lot, and it's going to give you a distorted answer. Now I'm going to enter in all my Y values, the grade averages, and make sure when you're entering the values that you match them up correctly. Now that all my data is in, I'm going to type the following into box 2. Y1 approximately mx1 plus b. And it tells me that my R value is -0.9005. So DESMOS just told us the correlation coefficient was -0.9005. This negative sign tells us that the linear association is going to be negative. A and B have negative, but C and D say positive. That means that C and D cannot be the answer. Next thing to consider is the 0.9. 0.9 is much closer to 1 than it is to 0. That means the linear association is strong. Answer choice A says strong and it says negative, so that's going to be my answer. B is incorrect because it says weak. Now let's pretend we were to plot this on an actual graph. Hours is on the x-axis because that's the independent variable, and grades would be on the y-axis. Let's talk about what this would look like based on that R value of negative 0.9. So because it's negative, we know the association goes down. That means that as the hours worked by the students increase, their grades decrease. It's a negative inverse relationship. The 0.9 means that the association is strong. So when you plot the points, they're going to be close together, not far apart. That means that the trend we just described is very likely to happen. There's a strong likelihood that when you work more hours, your grades are going to decline. I hope you guys enjoyed this video. If you need help with other topics, make sure you click follow.